Thank you all for coming to the last talk before lunch. I will try and keep it peppy so that we can all get to food. But like she said, my name is Kelley Hall. I'm a data scientist at Tableau, which is part of Salesforce. And I'll be talking about MLOps for the lonely data scientist. And you might be saying, Kelley, Salesforce is one of the largest companies in the world. How are you a lonely data scientist? But the reality is, for my team in particular, we are a really scrappy team. I'm the only data scientist in all of Tableau's sales org, and I work with 4 other data engineers. So I think we operate a lot more like a scrappy startup than we do a billion-dollar company, in that we have to build a lot of our own infrastructure, and our choices about what infrastructure we build comes at a cost of net new products. So we have to really justify that to our users. Also, the genesis of this talk actually came from this conference last year, where I was having conversations with people. I was like, yeah, good new models. What are you doing for your MLOps? How are you automating your systems? So hopefully this can be a pretty practical talk. I will say, when I submitted the abstract for this talk, Amazon told me that Catherine Nelson's book would be dropping in October, and it arrived on my front porch on Saturday. So hopefully this is more of a teaser of the concepts that are in this book, and if not, I'm happy to be corrected by her. But the idea is that even the scrappiest teams can benefit from investing in their infrastructure, and there are a lot of concepts from software engineering that we can borrow to build ourselves better infrastructure. So I wanted to start and give you the 3 key takeaways, so hopefully you can remember these throughout the talk. The first one is that we can borrow from software engineering best practices to help ourselves build more resilient code bases. One of the ways that we can do this is by separating our work into dev and production environments and keeping those 2 environments quite separate from each other. And then the last thing is using automated pipelines and Docker containers to productionalize our data. This is something that maybe you might think, like, you're one data scientist, you don't need to be doing this amount of infrastructure, but it really helps speed up my workflow. So one of the core concepts that hopefully everyone's familiar with, I'm not blowing your mind if we talk about version control, is using something like Git. So I'm not going to go into the details of how you use Git, but the things that you get from Git are the ability to make local changes without impacting your production data or your production pipelines. You can roll back changes really easily, and you can also enforce the fact that production changes need to be reviewed by a peer, or at least go through some vetting process. The other big concept that we're going to borrow from software engineering is dev versus production. So dev, short for development, prod, short for production. This was my metaphor for dev, that dev is like you are a gymnast tucking yourself into the foam pit, practicing your tricks. There's a lot of safeguards. No one else is viewing you as you're practicing your backflip into the foam pit. It's a safe space. And that is true for our code as well. So we can test our models in pipelines without impacting our customers downstream or the effectiveness of our application. This is code that has not yet passed some sort of peer review. And this is one thing we've really started to emphasize in our work, is that it writes into a separate database and or schema than our production data. And keeping these 2 environments really divested from one another is really important to our quality of work. And then your production data is hopefully Simone Biles at the Olympics, 10 out of 10 perfection. I know we're all launching perfect code into the world, but it's at least code that has passed some sort of peer review, it's passed some thorough testing in your dev pipeline, and it writes into your production database. So you'll see that, like, dev and production, I'm going to duplicate a lot of what I'm saying. That's the point. These 2 pipelines should be the same. That's how you're testing things. If they're different, you're not actually testing what your production life will be like. So I thought the best way... Well... We're still in dev. It's okay. talk, and then I'll see like what of that you still have questions about. Is that okay?
Yeah. Sorry about that.
That's maybe I pressed something. Okay, so I wanted to walk you through what a typical workflow for me looks like to kind of give you a picture of how we put this whole pipeline together. So let's say I want to add a feature or change a model. I'm going to pull down a copy from my remote branch to my local machine. I'm going to work on it, make my commits along the way, and then when I feel good about it, I'm pushing it back up to our remote or a pull request. I've yet to have someone successfully explain the difference between push and pull to me. But that in our infrastructure kicks off an automated job that builds a dev version of our Docker container. And this allows us to do that end-to-end pipeline testing without it impacting production. And so an example of this is I was viewing my dev data in a Tableau dashboard. This is my plug for Tableau. And I noticed that the way Snowflake was reading my date time as a string was saying that it was the year 20,000 instead of the year 2000. And so I was able to catch that before it went into production, go fix it, and then push up the new changes and have that be correct. So once it's past that testing, then I'm merging it into production, and that's kicking off a second automated job that builds that production container. For the visual learners in the room, this is an example of what I just said, but in pictures. So we have our production branch. I'm pulling a local copy, making commits along the way, feeling good about it, kicking it back up to dev, which is also a remote version, catching some error, making another change, and sending it all the way back up the cycle. I just think this is words are hard sometimes, so pictures are nice. You will notice that I mentioned Docker containers. I think Docker containers are a really good idea. Thank you for the pity laugh. If you don't know, Docker's logo is a whale. This is a great pun. If you don't know what a Docker container is, they're super, super powerful for being relatively simple. They are a lightweight, standalone, executable package of software that includes everything you need to run that software. So have you ever sent someone your Python code and they go, it doesn't work on my machine? And you have to go, are you on a Mac or are you on a PC? And they go, I'm on a Mac. And then, what version of Python do you have installed? 3.10. Oh, this was written in 3.11. And so on and so forth. So frustrating. Docker takes care of all of that because you are packaging up your package, redundant. You're wrapping up all of your packages into the Docker container, and it acts sort of like a virtual machine that you can run your code on. One of the beauties of Docker containers is also you are not reinventing the wheel. People have built you beautiful Docker containers to run your scripts. And this is also starting to treat your data science models like they are software packages. So we've started to treat our data science models like they're APIs and mimic the way that we interact with Anaplan or Workday. They are pieces of software. So to borrow another concept from software engineering, one thing we started to leverage is that continuous integration, continuous deployment, or CI/CD. This is something that GitHub or GitLab, it's a feature that you can use. And this is that automated job that I was talking about. So if there are things that you do every time you submit a pull request, for me, I used to manually be building those Docker containers to manually write the script to log into AWS, build the container, push it up to AWS. All of that is now contained in a script that happens every time I submit a pull request. Other things you can do with your CI/CD, you can enforce standards of code cleanliness, or maybe you want to enforce where you have your commenting in your scripts. Anything you want to enforce every single time, that's something you can incorporate into CI/CD. And this is what allows us to test in our dev environment prior to pushing to production. So our CI/CD job that one of the data engineers builds this Docker container, tags it with dev, and pushes it up so that we can run it end to end. So this is another example of what our pipeline looks like. In dev, we build a Docker container, we trigger it for using some sort of AWS feature, it writes data into our Snowflake database, and then we visualize it in Tableau. And you also might be saying, Kelley, you just duplicated 2 pipelines. Like I said, that is the point, that our dev pipeline is an exact mirror of our production pipeline so that we can test the failures at every single point. Is the Docker build bad and it's not running on AWS? Is it writing weird things to Snowflake? Are the columns out of order in the way that Tableau would read it? All of those things get tested before our analysts are interacting with the data. For me in particular, I build data science models that our sales leaders use in their forecast every single day. And trust me, they know how to find me on Slack if their numbers have changed, and they have. So I want to make sure that I'm very confident in what I'm sending out to them. I wanted to give an example of our full tech stack. The hardest part for me in building up this infrastructure was not even knowing what to Google. Like if you don't know that something exists, you can't Google that thing you don't know about. So this is an example of our tech stack. We are an AWS house, but you can find a similar thing in whatever service you want to use. So first, you need a place to store your containers. So we use Elastic Container Repository, or ECR. This is just basically a library of all your containers, and they can be tagged with dev or production. The next thing you need is some service to run your containers. So in AWS, there are 2 different services you can use. You can use Lambda functions. These are for lightweight things that take less than 10 minutes and are read-only. You could also just manually install packages into Lambda, but Docker containers are a really nice way to package all that up. The other, this is the one that I didn't know existed until one of my data engineers was like, well, why aren't you using Fargate? Did not know Fargate existed, thank you. So this is for models that take more than 10 minutes to run or need to write some temporary file to the container. And both of these services allow you to set a schedule in which they run, and also for you to monitor them with AWS CloudWatch. And then somewhere to store the data. This is something we've been recently implementing, is treating our data science models like they are an API like Workday or Anaplan where we're pulling data, and having it write, instead of straight into Snowflake or our database, having it write into an S3 bucket where we have a dev bucket and a prod bucket. And the reason why that's super helpful is sometimes you just write bad data into the database, and it can be really hard to delete that data back out if you just hard launched it into Snowflake. But if it's just a Parquet or CSV file in an S3 bucket that you're building out of a data lake, it's pretty easy to just take out that one file. The last pro tip I have is that we did not build our AWS instance from scratch on our 5-person team. We hopped onto our products AWS instance. We spend about $200 a month running all of our AWS stuff. So a blip in terms of what they are running all of Tableau on. But that meant that we got a lot of the security features and the hardest parts about AWS basically for free, like setting up your VPC, your IAM roles, everything that's made you go cross-eyed when you open up AWS's documentation. We got that for free. So I wanted to circle back and go back to our big takeaways, that there are a lot of practices from software engineering that hopefully you've seen. These are some pretty basic concepts from software engineering, but they help us build more resilient code and keep us from hard launching changes that might really impact our customers. I really want to emphasize separating your work into that dev and production environment and starting to think that way, and keeping those 2 environments as separate as possible so that you have a safe space to make your changes. And then the last thing is using automated pipelines like CI/CD and Docker containers to productionalize your code. And I guess I accidentally deleted this line, but I said, maybe not in a Jupyter notebook. Hot take for a data science conference, but Jupyter notebooks are pretty hard to productionalize versus a script. Git does not like Jupyter notebooks, so they're great for certain things like exploratory data analysis. They're pretty tough to productionalize, so consider moving into working on scripts instead of notebooks. All right, thank you, and I'll take time for questions.
Yeah. Did you guys roll your own pipeline, or did using? I think there are some like solutions out there already. I know Flight is one of them. And I think there's another company called like QBox.
This is the dark side of working for a giant company, is that getting something through security approval is like pulling teeth. And so for us, adding in, maybe there are companies that have built pipelines that we could just hop into, it would have taken us a year to get that through security, versus we can just build something relatively scrappy, it's already in stuff that's security approved, and build it in a month instead.
You kind of talked a lot about support from data engineers. Would your philosophy on this change if you didn't have as much support from a data engineer? Or what would you cut out first, I guess?
Well, I think two things happened for me personally, is my manager went from being a data scientist to being a data engineer, and that's when the emphasis on our team became a lot more of this infrastructure. I think for me, I was still building things into Docker containers and Lambda. I was maybe less stringent about where the data was. I was just hard writing into Snowflake. So that's some of the stuff where I was like, that's a nice to have of having a production and dev database. You can maybe work your way around that without having to get, again, your security or your BT team to create you a whole new database.
So as you mentioned, if you don't even know what to Google, you're kind of stuck. So what would you say in your experience were the best resources for learning what to Google?
I will say it was one of our data engineers. I think Fargate was the thing I did not know existed, and for months we had been putting off automate. We have a job that runs every month, and every month I had to sit down at my computer and hit start. That's insane. And for months we were talking about, we should automate this, we should automate this, we should automate this. And then one meeting he was like, well, why don't we use Fargate? And I was like, where were you months ago? So I think finding whatever service you want to automate your jobs is maybe where I would prioritize. And I think you could go Fargate, Lambda, and use that as your seed query to be like, how do I do Fargate but in Azure?
I have a question. What made you go with ECS and Fargate as opposed to Kubernetes, KS?
I will say, I think this is how we all kind of do our work of someone tells you one way to do it and it works. And I had heard of Kubernetes, but again, the easiest lift is the path that someone already knows how to do. So that's how we landed on Fargate. I think the best things we get out of Fargate are, it's going to pick, what it's doing on the back end is firing up an EC2 instance for you, and elastically scaling for the demand you have. That's a lot of jargon to say it's picking the right size of machine to run it on, and that's just really nice for us because it only runs once a month. So we don't need to spin up something that's on all the time.
So when you're working in the dev versus prod environment, do you have the same repo in Git that you will run in dev and then in prod?
Yeah, so the way we've set up our script is that every branch has to start with the prefix dev dash and then whatever you want to name your branch. And that tells the shell script that's happening in GitHub to run the CI/CD, it tells it what to do. It tells it that, oh, if this is a pull request, I'm going to build this tagged dev. Does that make sense?
Yeah.
And then I think the difference is when you're merging, because that's a different action to GitHub, it knows, okay, if I'm merging, I should build it in production.
So with the dev versus prod, do you work with any PII and the security aspects, or you just, is everything super secure and you don't have to worry about that?
Thankfully, we don't have any PII, and everything's kind of, because everything's within our sales database already, it has security on itself. When we get into our Tableau dashboards, we have to do other security things, but that's not necessarily dev versus prod. I think the one thing I forgot to mention that is important is that your dev environment can read from prod, but prod cannot read from dev. So I'm running my dev models looking at production data. Like I'm not building a model off of, I will say, they did at one point ask if we could build our data science models off of fake data because dev shouldn't have prod.
Yeah.
Insane. But no, so our dev models pull production data but push dev results. So that pedantic thing. All right, that is our cue for lunch. Thank you all so much for coming.